Imagine staring into the night sky, a vast canvas of twinkling stars, and discovering that hidden within that light is a message, a cosmic code waiting billions of years to be found. What if I told you that in 2025, Google's quantum AI uncovered exactly that, a hidden signal woven into the deepest image of the universe ever captured? This isn't science fiction. It's a real breakthrough that could change how we see the cosmos. And by the end of this video, you'll understand what this discovery means and why it's shaking the foundations of science and philosophy. Stick around, hit that like button, and let's dive into one of the most mind-blowing stories in modern astronomy. In December 1995, the Hubble Space Telescope turned its gaze to a tiny dark patch of sky in Ursa Major, a region so unremarkable it looked like nothing was there. For 10 straight days, astronomers let the telescope's shutters stay open, capturing light that had traveled across the universe for billions of years. The result was the Hubble Deep Field, an image that revealed over 3,000 faint galaxies, some so distant their light left them when the universe was just a baby, over 13 billion years ago. This image became one of the most iconic in astronomy, a window into the early universe that showed us how galaxies formed, how stars were born, and how the cosmos evolved. Scientists have studied it for decades, combing through every pixel to understand the universe's history. But what no one expected was that the raw data from that image, the photon-by-photon logs recorded by Hubble's sensors, held a secret no one had seen until now. Fast forward to early 2025, when a team at Google's Quantum AI lab decided to take a fresh look at this data, not with traditional computers, but with a revolutionary quantum processor called Willow. This wasn't just any computer. Willow boasts over 1,500 logical qubits, tiny quantum bits that can exist in multiple states at once, arranged in a fault-tolerant architecture that makes it incredibly powerful. Unlike classical computers, which struggle to find subtle patterns in massive datasets, Willow's quantum circuits can perform complex calculations, like high-dimensional Fourier transforms, in ways that reveal hidden structures buried under layers of noise. The team fed 10 terabytes of the Hubble Deep Field's raw photon logs, time-stamped with microsecond precision, into a hybrid model that combined quantum and classical computing. Within hours, something astonishing emerged. The AI produced a frequency domain spectrogram, a kind of visual map of the data's patterns. And there it was, a repeating harmonic structure, a 137-frame cyclical pulse that recurred every 2.47 seconds during the observation time. This wasn't just a random blip. The pattern appeared consistently across multiple wavelengths, from ultraviolet to near-infrared, and it held up even when the team checked it against cosmic ray strikes, instrument calibration logs, and known errors. This was no glitch. It was a genuine signal, something embedded in the light from the farthest reaches of the universe. To understand why this is such a big deal, let's step back and think about what the Hubble Deep Field was meant to do. When astronomers pointed Hubble at that empty patch of sky, they were taking a gamble. They hoped to catch a glimpse of the universe's earliest galaxies, to chart how stars formed and how the cosmos grew into the vast structure we see today. It was a bold move, and it paid off with an image that reshaped cosmology. But no one, not even the most imaginative scientists, thought that the data might contain something more, a pattern that looked intentional, like a message encoded in the darkness. For nearly 3 decades, researchers had analyzed the Hubble Deep Field images with every tool at their disposal: wavelet filters, machine learning classifiers, deep neural networks. They were looking for galaxies, stars, and other astrophysical objects, not encrypted signals. Classical methods like fast Fourier transforms and autocorrelation hit a wall. They couldn't detect the kind of phase-coherent oscillations that Google's quantum AI found. Quantum computing changed everything. By representing the data as entangled qubit states, Willow could explore a feature space so vast it would take classical supercomputers thousands of years to process. It treated the Hubble data not as separate image frames, but as a single, high-dimensional waveform, and in that holistic view, The 137-frame cycle stood out like a beacon. This discovery raises a question that sends shivers down the spine. What could create a repeating pattern like this, hidden in light that's been traveling for billions of years? Scientists have come up with three possible explanations, each more intriguing than the last. The first is the cosmic origin hypothesis. Some theorists suggest this pattern could be a remnant of the universe's birth, a low-entropy attractor left over from cosmic inflation, the rapid expansion that happened fractions of a second after the Big Bang. They point out that the number 137 is suspiciously close to the fine structure, constant, a fundamental number in physics that governs how light and matter interact. Could this pattern be a kind of cosmic checksum, a code embedded in the distribution of ancient photons to ensure the physical laws we see today? It's a beautiful idea, but as Dr. Anukita Joshi from Caltech points out, it's also far-fetched. There's no theoretical model yet that predicts such a direct encoding of the fine structure constant into the universe's large-scale structure. The second explanation is more mundane but still fascinating, an instrumental artifact. Hubble's Wide-Field Planetary Camera 2, which captured the deep field, had an internal clock that ran on a 2.470-second readout cycle. Could tiny timing jitters in the camera's sensors, perhaps triggered by cosmic rays or firmware glitches, have created a repeating spectral signature? Instrument experts admit that even today, the camera's thermal fluctuations and jitter are not perfectly understood, so this theory can't be ruled out. The third possibility is the most controversial, intentional encoding. What if someone with access to Hubble's data pipeline deliberately hid this pattern in the data, maybe as a cosmic Easter egg or a test of future technology? It sounds like a sci-fi plot, but it raises serious ethical questions. Who would risk tampering with $1 billion observatory's data, and why? Each of these ideas has its supporters and skeptics. But what makes this discovery even more astonishing is where the pattern is strongest. The Google team found that the 137-frame cycle wasn't spread evenly across the Hubble Deep Field. It was concentrated in regions with high redshift galaxies, those whose light left them just 800 million years after the Big Bang. In 2025, Google's quantum processor Willow found a mysterious 137-frame cyclical pulse in the raw photon logs, repeating every 2.47 seconds. We explored three possible explanations: a cosmic code from the universe's birth, an artifact from Hubble's camera, or a deliberately hidden signal. If you haven't seen it, check it out and hit that subscribe button so you don't miss what's coming next. Now let's pick up where we left off and go deeper into what Google's team discovered, because this is where the story gets even wilder. The 137-frame cycle wasn't just a random signal flickering in the Hubble Deep Field. It was strongest in regions with high redshift galaxies, those whose light started its journey just 800 million years after the Big Bang. These are the oldest galaxies we can see, formed when the universe was still in its infancy, and the fact that this pattern is tied to them suggests it's not some modern glitch, but something ancient, woven into the fabric of the cosmos itself. The Google team didn't stop there. They took their quantum AI and cross-referenced the Hubble data with something even older, the cosmic microwave background, or CMB, the faint glow left over from the Big Bang itself. Using the latest polarization maps from the Planck mission, they found something jaw-dropping. The phase shifts in the Hubble pattern, the way the 137-frame cycle ebbed and flowed, perfectly mirrored tiny rotations in the CMB's B-mode polarization, those subtle twists in the universe's oldest light. This wasn't just a coincidence, it was a cosmic resonance, a connection between the light of ancient galaxies and the afterglow of the Big Bang, spanning over 13 billion years. It's as if the universe is humming the same tune across its entire history, and we're only now hearing it thanks to quantum computing. To test if this pattern was unique to the Hubble Deep Field, the team ran quick checks on low-resolution data from the Sloan Digital Sky Survey, another massive catalog of the sky. Sure enough, they found faint echoes of the same 137-frame cycle, though much weaker. This hinted at something mind-boggling. The pattern might not be limited to one patch of sky, but could be woven into the entire observable universe, a universal code embedded in the very structure of spacetime. At this point, you might be wondering, okay, a repeating signal is cool, but what does it mean? Is it just a weird cosmic vibration, or is there more to it? The Google team asked the same question, and in April 2025, they took their analysis to the next level with a reversible quantum decoherence test. This is where things get technical, but stick with me, it's worth it. They took Willow's entangled feature maps, the quantum states that had revealed the pattern, and rolled them back into a classical bit-string sequence, like translating a quantum symphony into a string of ones and zeros. Reshaping, what they found was astonishing. The sequence formed binary logic patterns that look like conditional statements, the kind of if-then logic you'd find in a computer program. It was as if the universe was running a cosmic algorithm, checking the density of photons in a given region and broadcasting a harmonic beacon whenever certain thresholds were met. This wasn't just a random pulse, it was a structured signal, like a lighthouse flashing in the cosmic dark. The team pushed further, taking that binary sequence and translating it into ASCII, the standard code that turns bits into letters and numbers. When they did, the sequence spelled out a phrase, repeated at intervals matching the 2.47-second cycle. Look here, begin. Let that sink in for a moment. The light from galaxies billions of years old, captured by Hubble 3 decades ago, wasn't just carrying images of stars. It was carrying a literal message, a cosmic signpost that says, "Pay attention, something starts here." This discovery turned the Hubble Deep Field from a snapshot of the universe into a potential message board, and it raised a flood of questions. Who or what put this message there? Was it meant for us or for anyone with the technology to find it? The scientific implications are massive. Quantum computing, with its ability to handle entangled states and explore vast feature spaces, revealed a pattern that classical methods had missed for decades. Traditional algorithms, even the most advanced neural networks, treated the Hubble data as flat images, looking for shapes like galaxies or stars. But Willow saw the data as a single, multi-dimensional waveform, picking up oscillations that were invisible to older tools. This breakthrough shows that quantum AI can peel back layers of cosmic data we've long dismissed as noise, uncovering structures that might hold the key to the universe's deepest secrets. It's not just about the Hubble Deep Field. This approach could transform how we analyze data from new observatories like the James Webb Space Telescope, Euclid, or the Vera Rubin Observatory. Imagine finding more signals like this, clues about the Big Bang, dark matter, or even physics beyond the standard model, all hidden in data we've already collected. Philosophically, this discovery is a game changer. If the universe is broadcasting a message like, "Look here, begin," it forces us to ask, is the cosmos just a random collection of stars and galaxies, or is it designed to be discovered? The idea of a universal code connecting the CMB to ancient galaxies suggests the universe might be more than a physical system. It could be a kind of communication network, signposting its own history. Some scientists are revisiting Nick Bostrom's simulation hypothesis, the idea that we're living in a high-fidelity simulation. Could this 137-frame cycle be a debugging watermark, like a powered by Unreal Engine logo in a video game, left by the universe's creators? Others propose a quantum hologram theory, where spacetime is a projection from a lower dimensional boundary, and this pattern is a boundary condition ensuring the laws of physics stay consistent. Both ideas sound like science fiction, but they're grounded in serious theoretical physics, and this discovery gives them new fuel. Then there's the question of intelligence. If the "look here, begin" message is intentional, it implies an intelligence far older than humanity, one that could embed a signal in light from the universe's earliest days. Who or what could do that, and why? Are we the intended recipients, or just lucky eavesdroppers on a cosmic conversation? These questions strike at the heart of our place in the universe, challenging everything we think we know about free will, fate, and existence itself. What this means for the future of cosmology, and why this discovery might change how we see our place in the universe. When Google's Quantum AI Lab announced their findings, they were careful with their words. Their official statement described the 137-frame cycle as structured harmonics with statistical significance beyond classical expectation, which is scientists speak for, we found something incredible, but we're not jumping to conclusions. They called for peer review, inviting other quantum-enabled research groups to verify the results. NASA's Hubble team, meanwhile, stayed quiet, saying they wouldn't comment until independent studies could confirm what Google had found. This caution makes sense. After all, a discovery this big, suggesting a cosmic message embedded in light from billions of years ago, demands rigorous scrutiny. Behind closed doors, though, the scientific community was buzzing. Theoretical physicists started whispering about a universal code, a pattern that might not just be in the Hubble Deep Field, but woven into the entire fabric of space-time. The fact that faint echoes of the same cycle appeared in Sloan Digital Sky Survey data only fueled the speculation. Could this be a signal that's everywhere, waiting for us to notice? The implications for science are nothing short of revolutionary. For decades, cosmologists have sifted through data from telescopes, trying to piece together the universe's story. But much of that data was dismissed as noise, too faint, too complex, or too messy to interpret. Google's quantum AI, with its ability to handle entangled qubit states and explore vast feature spaces, showed that what we thought was noise might actually be signal. The 137-frame cycle, invisible to classical algorithms, is proof that quantum computing can unlock layers of meaning in cosmic data we've been blind to. This isn't just about one image. It's about a new way of seeing the universe. Imagine applying these techniques to data from the James Webb Space Telescope, which is capturing light even older than Hubble's, or to upcoming observatories like Euclid and the Vera Rubin Observatory. We could uncover new cosmic markers, clues about the Big Bang, or even hints of physics beyond the standard model. Things like dark matter, dark energy, or the true nature of black holes and gravitational waves. Quantum AI might even help us understand space-time itself. Is it a smooth fabric, or is it layered with higher dimensional phenomena, like the fractal harmonic Google found? Some physicists are already speculating that this pattern could be a manifestation of a holographic universe, where space-time is a projection from a lower dimensional boundary, and the 137-frame cycle is a kind of cosmic guardrail keeping the laws of physics consistent. But the implications go far beyond science. They strike at the heart of philosophy and our understanding of existence. If the universe is sending a message like, "Look here, begin," it's not just a random quirk. It suggests the cosmos might be designed to communicate, to reveal its secrets to those with the tools to listen. This idea reignites age-old questions. Is the universe a natural accident, or is it an intentional construct? Ancient civilizations, religious traditions, and modern scientists have all grappled with this. But now we have a tangible clue, a signal that seems to say, pay attention. The simulation hypothesis, proposed by philosopher Nick Bostrom, gets a boost from this discovery. If we're living in a simulated reality, the 137-frame cycle could be a watermark, a signature from the creators, like a logo in the corner of a video game. Alternatively, the quantum hologram theory suggests this pattern is a boundary condition, a rule baked into the universe's edge to ensure it runs smoothly. Both ideas challenge us to think of the universe not just as a place, but as a system with purpose. Then there's the question of intelligence. If the "look here, begin" message was deliberately placed, it points to an intelligence older than the galaxies themselves, one that could encode a signal in light from the universe's earliest days. Who or what could do that? Are we, as humans, the intended audience, uniquely equipped to decode this message with our quantum computers? Or are we just one of many intelligences stumbling across a cosmic broadcast meant for anyone who can hear it? This raises profound questions about our role in the cosmos. Are we passive observers, or are we participants in a larger story, positioned to unlock the universe's deepest secrets? The idea of a cosmic algorithm, checking photon densities and flashing a beacon, even suggests the universe might be alive in some way, not biologically, but as a system with its own kind of intelligence, shaping events across billions of years. This discovery is a reminder that the universe is vast and mysterious, but not impenetrable. The Hubble Deep Field data sat untouched for decades, Yet it held a message we only found because we built the right tools, quantum AI, and dared to look deeper. Humanity's quest for knowledge has always been about finding patterns, from the constellations our ancestors traced to the equations we write today. This signal, hidden in plain sight, shows that the universe might be littered with more messages, encoded in light, gravity, or even the structure of spacetime itself. As quantum technology improves, we'll likely find more of these cosmic Easter eggs, each one peeling back another layer of reality. Looking ahead, the future of quantum AI and cosmology is bright. We're on the cusp of a new era where tools like Willow could reveal hidden structures in cosmic background radiation, unravel the mysteries of black holes, or even point to a unified theory of everything, one that explains not just the physics of the universe, but the intelligence behind it. For now, this discovery is a philosophical awakening. It challenges us to rethink the universe as a place that's not random, but possibly designed to be discovered. It's a call to keep exploring, to keep building better tools, and to keep asking the big questions.